All right, part 2 of semester 2 final review, starting off with chapter 10 with circles. So, remember, make sure you're taking good notes so you can take these from your review to your note card when you get that. So, area of a sector. Remember, area of a sector and arc length are very similar to each other. There's one difference. It's what formula you use at the end. So, for area of a sector, okay, what are we comparing this to?
T.
Correct. Yep, this is the angle measure, but what is that measure angle out of? The whole thing. Yep. Times, now I'm talking about the area, so what am I multiplying by? 2 pi r or pi r squared? Pi r squared. Yep, so for area of a sector, the main difference here is you're multiplying by the whole area of the circle. So now we just plug it in. What's my main angle of this sector? Yep, 42 over 360 times pi, what's the radius? 8, and then squared. What needs to happen first before you plug it into your calculator? Do this first. 8 squared, get rid of that first, and then you can type in your calculator. Final answer you should get is 23.5. All right, on 22, we are talking about the equation of a circle. So what's important for that is to know what the equation of a circle is. So x minus h squared plus y minus k squared equals r squared. What are the two most important things in order to write that equation? Center, which is, I heard, hk, and radius. Where do we get the radius from? In this equation, it stands for r. What's the center of this equation, or of this circle? 3, negative 1, good. And then how do I figure out what the radius is?
Just count.
Count from the center to the edge. You can go in either direction, it does not matter. So 1, 2, 3, 4, radius is 5. Now it's just a matter of plugging it into the formula. Am I ever going to plug values in for x and y? No. No. Plug it in for h and k and r. So I have x minus 3 squared plus y minus negative 1 squared equals 5 squared. Can I leave my answer like this? No, make sure you finish all the way through. So this is x minus 3 squared plus, what's this turn into? Y plus 1 squared equals 25. Once you have it simplified here, that's your final answer. If you start here and you can go directly to this, that's fine. Okay, you don't have to show all that work there if you don't want to. All right, on number 23, talks about finding a missing side length of a specific segment. So we're looking for that RS there. What kind of lines do we have? We have a tangent, which is this one. I agree with you, this is a chord, but the whole thing, I heard someone say it, is a secant. Yep. So let's talk about that tangent line. How do we set this up in an equation? 11 squared, good, equals, secant ones are a little tricky. How do we set up the secants?
7.
Yep, outside. So what I mean by outside is outside the circle. So that part is 7 times, then I want the whole thing. How would I find the total of this? X plus 7, or 7 plus x. Yep. Once you have that set up, the rest is algebra. So what's 11 squared? 121 equals, what am I doing on the right side? Yep, distribute here. So I get 7x plus 49. Make sure you distribute to both. From here, subtract 49. So I get 72 equals 7x. Last step, divide by 7. X equals 10.3. Good. Number 24 has 4 different parts to it. They all kind of go together. So on part A, it wants us to find the measure of angle ABE. If it helps, draw the angles out. It'll show you what you're looking for. Okay, so right now I'm looking for this angle. Is that angle a central angle or an inscribed angle? Inscribed. What helps find inscribed angles? It's their arc, right? So this angle is created from this arc here. So since I know its arc measure, how do I find its angle measure? Bingo. Yep. Take 96 divided by 2, which gives you 48. Once you find one of them, fill it into the picture, okay, because it'll help you with the rest. Part B, it wants to know what BAC is, so this angle measure here. It's an inscribed angle, right?
Yeah, 118.
Yep, take its arc, 118, divide that by 2. What's 118 divided by 2? 59. Again, fill it into your picture. Part C, it wants to know AEB. That's this angle right here. Now, is that a central or an inscribed angle? Trick question. Is it any of them? No, it's not right in the center, and if it's inscribed, where does it have to be? On the edge, right? It has to be on the edge of the circle. So it's neither. There's a couple different ways we can find it. What's probably the easiest?
48 plus 59.
Bingo. What you want to see is this triangle right here. What do we know about all angles of a triangle? They all add up to 180. So we can take 48 plus 59 to give you 107. What do I take with that 107? Yep, 180 minus 107 is 73. Good. And then that last one there wants to know BEC. So this angle here. Couple different ways you can do it. What's the easiest? Where are you getting 180 from? How do we know 180?
That's the line.
It's on a straight line. Yep, it's on a straight line. So what do we know about these two angles? Have to add up to 180. So we take 180 minus 73 to give you 107. Any questions on either of those? If you had a central angle question, okay, if you had a central angle question, and I told you that this is 120, if the arc's 120, what's its angle measure? 120. Yep, remember central angles and their arcs are the same. Okay. All right, moving on to number 25. This time we're talking about arc length. So this one's very similar to area of a sector, okay, but what's the difference? So we still have measure the angle divided by 360 times the circumference. Yep, 2 pi r. Yep, arc length, we're talking about the distance from here to here, so we want to compare that to the circumference. So what is my angle measure? 42 over 360 times 2 pi times 8. And if you type that in your calculator, you should get, not that, 5.9, thank you. Number 26, still talking about circles. What kind of lines do I have? Chords, I have 2 chords. How do we set up chords? Yeah, so if I'm talking about SQ here, what makes up SQ? 9 and 16, what do I do with those? Yep, 9 times 16. And then what makes up this one? Yep, so I take 8 times 5x plus 3. Turns into algebra. Here, this gives you 144 equals, what do I do here? Yep, make sure you're distributing to both. We get 40x plus 24. What's next here? So I get 120 equals 40x. Yes, sir.
Do you always start with like the shorter line when you set
It really doesn't matter. Nope, it does not matter. Last step, divide by 40. X equals 3. So were you talking about the order of these? Yep, that doesn't matter. Okay. Number 27. It wants to know what is the measure of arc XY. So here's arc XY. Can I say that it's 99?
No.
Why not?
It's not easy.
Right. If I had this, can I say 99? Yes. But we don't. So what can I do?
Take 3 minus
9 minus 365.
Okay. What do we know XY relates to? What's it the same as? So do you agree I can mark all of these as X?
Yeah.
Because they're the same value? Okay. Now, I heard a lot of you say it. What do all of these add up to? 360. So we can set up an equation. If I add all four of these, okay, I would get 3x plus 99 equal to 360. Yep. Next step. Yep. So I get 3x equals 261. Last step. Divide by 3. X equals 87. Yep. What if it wanted to know x, y, z? Yeah, both of these equal 87. Do you agree? So how would you find the total length?
I'm good.
You would add them, or you would multiply 87 by 2. Yep. Good. And this one would also be 87. Awesome. Number 28. It says line GH is tangent to the circle. Why is that information that we need to know?
That means it's a right angle.
It gives you a 90-degree angle. So I'm going to mark this as 90. Understand that this side is also 90. Okay. It also says angle ANG is 54. Now, there are multiple different ways you can do this problem. What did you guys think of? Sorry, it wants us to find AB.
90 minus 54.
So you both did it a different way, right? I want to talk about what Peter said real quick. What do we know these two add up to?
90.
90. So I can take 90 minus 54, which is
30.
36. So that gives me this angle right here. How did that help us?
But you can multiply by 2.
Right? Yep. I know its angle. To find its arc measure, I just take 36 times 2, which would be 72. So that's one way you can do it. Just for a review, in case it'll help you on the final. If I know that this is 90, what's its arc measure? How do you find that? A lot of you see this, duh, it's 180. But if you didn't see that, just take 90 times 2. Remember, multiply out. So we'd get 180 there. How would I find this arc measure here?
Then you just 17 plus 180. And 360 minus.
Yep. I can add these two and subtract from 360, or I could do what?
Just subtract 72 from 180.
I could take 72 from 180, good, or multiply that by 2. Yep. See how there's a lot of different ways you could have solved this problem? Bunch of different ways. Okay. Any questions about that one? Your overall answer for that one should be 72. All right, number 29. It's talking about a circle, but what do you probably not like about this problem? There's a word problem. What does it not have?
A circle.
It doesn't have the picture, but are you fully capable of drawing that?
Sure.
Yes, go ahead and draw yourself a circle. It says a chord is 8 inches. How do I draw a chord? Yep, connects the two, the endpoints are on the circle, and it tells me that is 8 inches long. Okay, and then it tells me from the center it is 1 inch away. So do you agree that marks this? Okay. I'm going to ask you this. What does that line from the center to the chord do to the chord?
Cuts it in half.
It does cut it in half. Good. So what would this side length be? 4. It does something else.
Right angle.
It creates that right angle there. Yep. So good. We have our right angle here. Now it wants to know what the radius is of the circle. Do we have our radius drawn yet?
Draw one.
We can draw one. I'm going to ask you this. Does it help if I draw a radius right here?
No,
Why not?
because just
Where should we draw the radius?
Straight down. Like straight.
Right here?
from the cord to the center, like the end of the cord to the center.
Yeah. Why should we draw it right here?
So we can use Pythagorean.
Bingo. It makes a right triangle. Okay. Always use right triangles when you can. So I'm going to label this as X because that's what we're looking for. Remember, radius is from the center to the outside. So using Pythagorean theorem, because it's a right triangle, what do I plug in for C? Yep, across from that right angle is X. Good. So we have X squared. What's my A and B? Yep, good. Okay, 1 squared. 1, 4 squared. Good. Add those together, I get 17 equals X squared. Last step always for Pythagorean theorem. Square root X equals 4.1. So remember, draw yourself a picture, make that right triangle. Okay, put the radius where it helps you. Create the right triangle. Moving on to chapter 11 with the 3D shapes. Starting with number 30, what do we know about the relationship between vertices, faces, and edges?
That's equal to as
Bingo. Yep. Euler's formula. F plus V equals edges plus 2. Do I have to have that plus 2? Yes, it's a part of the formula. Okay, so I'm going to do a couple of these with you. You're going to fill in each missing piece of the table. So if I plug it into the formula, I get 4 plus 4 equals edges plus 2. Can I turn this into 2x? No. Keep that plus sign in between them. We get edges plus 2. If I simplify that, I have 8 equals edges plus 2. How do I solve from there? I would subtract 2, edges equals 6. A lot of us are putting 10, like we're getting it the other way. Okay? Some of us are doing that because we're not just showing the simple work and going through that. Okay? Take the time to do that so you don't get them wrong and make silly mistakes. Let's look at the last one here. Look at this one. If I do 6 plus f equals 12 plus 2. So this turns into 6 plus f equals 14. Last step. Subtract 6. F equals 8. So we get 8 total. And you would do the same thing for those last 3. Very similar on number 31. How do we know if it creates a polyhedron or not?
Make sure they're equal.
Use the formula to see if it's a true statement. Okay, so how many faces do I have? 8 vertices, 4 edges, 10. Do I need the plus 2? Yes. 8 plus 2? 12. 10 plus 2? 12. What does that tell you? Yes. What would it look like if it was no?
It would be unequal. 13.
Sure. 13 equals 12. Good. Next one, 32, we are talking about surface area. Okay, I will talk about the formulas at the end here in a second. So, finding surface area, round your answers to the nearest tenth, and don't forget what? Label. I got that as a reminder for you. So, in general, what is that shape on A? It is a cylinder, so you're going to look on your note card, 2 pi r plus h. What is the radius? Yep, remember, look for that circle if you need to. Don't forget to cut it in half. Radius is 2, height is 2. Then we just plug it in. So I have 2 pi times 2 times 2 plus 2. What do you probably need to do first? 2 plus 2, yep. Refrain from silly calculator mistakes. Do all the math that you can first before you use your calculator. If I multiply all that together, I get 50.3 kilometers squared. Yep, surface area is squared. Good. Part B, what's the general shape there? Prism, yep. More specifically, rectangular prism. Good. What helps find all of the things?
Shade the face.
Shade the base. Here's my base shape. How do I find capital B? What does capital B stand for? Area of the base. How do I find it? 9 times 2, which is 18. What does capital P stand for? Perimeter of the base. Yep, so remember, I just want the perimeter of this base shape. What do I add together? 9 plus 2 plus 9 plus 2, which gives you 22. And then how do I know what the height is? Connects the bases, which in this case it's 6. Yep. Once you have all of those, plug it into your formula. We have 2 times 18 plus 22 times 6. Do you just add together right away? No, make sure you do the multiplication first. So this turns into 36 plus 132. Final answer.
168
168
centimeters squared.
centimeters squared. Good. Okay. And then part C here, what's the general shape? Pyramid. Yep, so here's our pyramid formula. How do I find the area of a triangle? Base times height divided by 2. What helps know what the base and the height are? Connected to the right angle. Yep. What is connected to the right angle on the base? Good. Yep. 7 and 6.1. So we take 7 times 6.1 divided by 2. That will give you 21.35. What do I add together for perimeter? Yep. Equals 21. And then what's this guy stand for? Slant height. Up the side is 6.3. Good. Some of us get all of these and then we get to the equation and we fumble it a little bit. So let me talk about this one more time. What needs to happen first? This whole thing has to happen first. This will always come last. Okay, so if I do that, I have 21.35 plus 66.15. Now I can add them together. Okay, so final answer in the end is 87.5 feet squared. Good. Don't forget labels. All right. All right. Volume now. Switching your brain a little bit. What's going to change mainly on these compared to surface area? It's the label. Yep. Got a cube. So what's the general shape here? Sphere. Yep. Volume equals 4 pi r cubed divided by 3. What's the only thing you have to know for spheres? Radius, which is 6.2. Plug it in. What should you probably do first to eliminate calculator error? This right here, cubed. Final answer on this one is 998.3 centimeters cubed. All right, what about part B? What's the general shape? Prism. Yep, this is a prism. How do we know the difference between a prism and a pyramid? Pyramid goes to a point. Prism has how many bases? 2 bases. Yep. Again, shade that base shape. How do we find capital B? Area of the base shape, which is a triangle. So we have to do base times height divided by 2. What's the base and the height? 12 and 4.6. If we do that, we get 27.6. What is the height? Yep, height connecting the 2 bases, 12. What do I do with those 2 numbers? Yep. If I do that, final answer, we get 331.2 centimeters cubed. Okay, and then part C, what is the general shape here? Cone, so we use volume equals pi r squared h divided by 3. What's my radius there? Yep. And height, 14. Plug it in. We get pi times 7 squared times 14 divided by 3. What should you probably do first? Squared. Yep, do that squared first. Final answer you should get 718.4 miles cubed. Some of us even forget the division at the end. Make sure you're doing the whole formula, not just stopping at that top part. Okay. If you come to me on test day and say, I don't know what the formulas are, what am I going to tell you? Should have wrote it on your note card. Am I giving you the formula sheet? No. If I gave you the formula sheet, I wouldn't give you the note card. Okay. So make sure you are doing what on your note card? Writing these formulas. Okay. Where can you find the formulas at? I have extra copies over here in my room, or it's on Google Classroom under Chapter 11. Okay, that formula sheet's on there for you. So make sure you are putting that on your note card. Capiche?
Are we doing the note card today or tomorrow?
Tomorrow, mostly. So number 34, talking about true and false. Are these going to be the same exact true and false questions on your test?
Yeah.
No, they will not be. Okay, they are going to be general geometry facts for true and false. Okay, I'm not trying to trick you on them. Okay, they should be straightforward geometry facts. Okay, so let's go through these. 34A, it says a triangle can have more than one right angle. True or false? That is majorly false. Part B, no one noticed this until 6th period. I had it wrong on the key. Yep. So it says the sum of the interior angles of a quadrilateral is 360. It is true. Yep, I put false because I didn't know this said quadrilateral. Okay, so I'm going to do something real quick. If I change this to, for example, a triangle. Now that's false. Why is it false? Should be 180 instead, or what should this say? Exterior. Yes. Good. Part C, a circle is a polygon. Why is this one false? It's round. It doesn't have any sides. Yep. Remember, is a sphere or a cylinder or a cone, is that a polyhedron? No. Part D, the exterior angles of any polygon always add up to 360. True. E, the Pythagorean theorem applies to all triangles. Why is that false? Only right triangles. Good. And a trapezoid has exactly one pair of parallel sides. True. Yep. All right. Any further questions for the good of the recording? All right.